is the point at which we get things out. So if you're at standard temperature and pressure, the vapor pressure is 1 atmosphere. Okay, it's how much vapor you're getting out to evaporate in a closed container. Okay, so evaporation, vaporization is in equilibrium with condensation when you have a vapor pressure. Okay, anything else you'd like to know with that? Go over to CE Chem 110. Okay. Anything else with just that? There was just a little section that you went over last night. A lot of last period about the triangles. That's just going from solid, liquid to gas, and what happens when you go one direction, what happens when you go the other direction. Okay. Yes. This is just, yeah, I can't remember where they put the solid on that one. Did they put it at the top or the? Okay, it's just a chart. I'm just going to choose where mine are going. So that would be represent this. And on one of them you say, okay, if we go from this to this, that's called sublimation. If I go from here to here, it becomes solid to liquid is melting. From here to here, liquid to gas is evaporation or vaporization. And then on the other one, you go backwards, and it would be called deposition. So let me go. It's just another way to look at it. Ew, that's deposition. Sorry, thank you. So we go this way for sublimation. And this way for freezing. And I've got to keep my arrows going the same direction. And this way for condensing. Okay. So that's all the triangles were. I know a lot of them were asking about those. Okay, anything else? Okay, let's grab your quiz then from last time. Let me give you the right answers, and let's see what ones you had problems with that you would like to go over. Now, if you didn't pick it up from the file, please go do that real quickly. So you're also getting a paper one this time. These are good things to go back over and study for the test. Okay. Okay. Figure this is a little bit more complicated, so it might be nice to have the right answers and be able to go back over and study. Okay, so number one, remember that we crossed out holding the temperature. It should have been pressure, so hopefully you did that. It is D, as in dog. Number two is B, as in boy.
Are we like grading this?
No, I just want you to have the right answers. I already graded it because you had it in the clicker. Number one is D, as in dog. Number two is B, as in boy. 3, cat. 4, apple. 5, boy. 6, apple. 7, boy. Did you not get it? It should have been in there because I didn't take any out. 8, cat. See if it fell on the bottom. Did you check? 9, boy. And 10, dog. Okay, so are there any that you were just like, got wrong and you just didn't know how to do it? Number 6? Okay. So number 6, again, as you go through it, pull stuff out. As you read it, pull it out and give it a letter. So a gas collected at a temperature 24.5 degrees Celsius. Right then I know I need to add, because I can't have any Celsius in my gas laws. And a pressure of 770.5 torr. And a volume of 0.820 liters. What will the volume, so I'm looking for V2. of the gas occupy at a temperature of 45.6 degrees Celsius. Again, I'm going to add 273.15. Under a pressure, P2, 523.4 torr. So we got a combined gas law. You can see right now I've got one of each kind. So I'm going to have P1 V1 divided by T1 equals P2 V2 divided by T2. Before I even get started, though, I'm going to add those ones together really quick at the top. If you guys got a calculator, if you'll do that fast for me, so we can just plug in one number. 0.65. Okay, so we got our temperatures. Now we are searching for V2. We're trying to get this one. And you can go ahead and just plug everything in and then solve for V2, but you know, I like to solve for the letter first and then plug everything in. Then I just have one thing to do. To do that, all I have to do is times through both sides by T2 and divide both sides by P2. So I end up with V2 is equal to P1 V1 T2 divided by T1 P2. Okay, and then I just plug in. The biggest mistake that I see on this one is people forget to put parentheses around the bottom numbers. Okay, so P1 770.5 torr times by V1 0.820 liters times by T2 318.75 K divided by T1 297. Did we say that was a 6.65 K times by P2 523.4 torr. Now, I remind you again, this bottom stuff, when you hit the divide side, needs to be in parentheses. Going through and canceling. Torr cancels. K cancels. I'm left with liters, which is what I wanted, is a volume. And I have three significant figures. So, plug that in. Let's see what we get for an answer. 1.29 liters. Yes, ma'am. You can do the extra credit quizzes, okay? But it's a good thing to go back and study from. So I would do it and try and get that right answer if it's the ones I got wrong, for sure, because there's going to be ones like that on the test, okay? All right, any others? Number 4. Okay, on number 4, it says, I have a sample that is occupying or has a temperature of 20.5 degrees Celsius again. So we end up with 293.65, yes. Okay, and a volume of 350.0 liters. What is the volume? So I'm looking for V2. If, question mark, if the volume is reduced by half, so we're not looking for the volume. The volume is reduced by half, so what do I need to do? Divide it by 2. So are you going to get 150 plus 25, 175? Yes? Liters. What will the temperature be if the pressure is held constant? Okay? So I'm trying to find temperature. Whose law is this one? Pressure is held constant. It's Charles, under constant pressure. So V1 divided by T1 equals V2 divided by T2. And we are searching for this should have been a 2. T2. So we're looking for this one. Again, I like to solve before to get it over with, so I'm going to have to move that up to this side and this down and that up. That looks messy. But it would be T2 is equal to V1 T1 V2, sorry, T1 divided by V1. That's a 2. So the 2 stays in where it is. So now we're just going to plug in. So we've got V2, 175.0 liters, times by T1, 293.65 K, divided by V1, 350 liters. Liters will cancel. We're basically taking 293.65, dividing it by 2, right? What do we get? 146.825, and that's K. But we only had 4 significant figures, so we're only going to go to here. And since it's in Celsius, we're going to have to do what to get to Celsius? Subtract 273.15, and we end up with about, right? Okay, yeah, I had one more back here, yes. Number 7 was B, as in boy. Yep, we can go over that. Okay, number 7. Okay, at a gas at a pressure of 1.55 atmospheres and a temperature of 34.0 degrees Celsius. Somebody do that one while I'm doing the rest. With a volume needs to be transferred to a container that is 1 liter. What temperature needs to be maintained in order to keep the pressure of the new container at 1 atmosphere?
So the temperature of the one is
307.15 K. All right, so we're doing the combined gas law again. P1 V1 divided by T1 equals P2 V2 divided by T2. And we are searching for T2. So I need to move it up. When I move it up, this comes down, and this goes up. So T2 is equal to P2 V2 T1 divided by P1 V1. Probably should do that in different colors. This one goes up. All right, so now we just plug in. Plugging in, we get P2, 1 atmosphere, times V2, 1.00 liters, times T1, 307.15 K, divided by P1, 1.55 ATM, times by V1, 2.50 liters. Remember again on the bottom, when you hit the divide, make sure that's in parentheses. Atmospheres are going out, liters are going out. We're left with K, which is a temperature, which is good. And we should end up with 158 K, is that right? Plugging it through. One more we can probably squeeze in. What?
Yeah, I got 79 also.
You got 79. Do we have a problem one? .15 divided by parentheses 1.55 times 2.5 close parentheses. I got 79 also there. So we have a problem. That one needs to be A. Number 7 should have been A. Okay. So I'll have to go back and fix that. See how it helps. Okay, well, there was one more that you guys want to do? Yes. Number 9. Okay, what volume in liters? What is the volume in liters? So I'm looking for volume. And they gave me a hint that R is equal to 0.0821 atmospheres times liters divided by mole times Kelvin. When she does that, you know what law are you using? PV equals nRT. Good. Okay, so it's giving me moles. N is 2.55 moles. And then it said at STP. So what's temperature? Okay, that's standard temperature for gases. Pressure. And we are solving for V, so rearranging the equation here. I'm plugging in. We've got 2.55 moles times 0.0821 atmospheres times liters divided by mole times Kelvin times by temperature, all divided by 1 atmosphere. Crossing out units, moles, moles, atmosphere, atmosphere. KK, we left with liters. And hopefully, when we plug that all through, we end up with 57.2 liters. Yes, ma'am. I do have some extras, actually. I was just going to use them as scratch paper. I'll just pass them around and you guys can. Got a 60. Oh, that's right. It's 273. Thank you. The temperature is off. I'm using standard for thermal. You guys don't need to know that. Okay, so 0 degrees, which is 273.15. Now it should get where we need to be. Sorry about that. I'm working with AP on thermal right now, so that's stuck in my head. And that's what I tell them. It's the one mistake a lot of kids make on the AP test because they get the thermal standard pressure and or temperature and the gas law standard temperature. Okay, any other, let's see, we probably need to go into lab real quick, real fast. If you have more questions on those, we can go through those. Hopefully we'll have some time when we get back. Okay, grab out your lab in front of you so you can sort of follow through with me. It is a very quick lab. It doesn't take very much time. Okay, it doesn't take very much time so that you can hopefully get through what you need to. So the first thing that we're going to do is we're going to use some equipment we haven't used before. The first one is a gas collection tube, which is basically just a long tube like this, and it has numbers on it. Okay? I'm going to walk you through what you need to do. You're going to go back there. You're going to get this tube. You're going to put 2 to 3 drops of universal indicator. It's in a little dropper thing in there. Okay? It won't go all the way to the bottom. It's okay. Then you're going to get a 10 milliliter graduated flask, and you're going to add to it 10 milliliters of 6 molar HCl. This is strong stuff. You don't want it on you. Okay, this is strong stuff. You don't want it on you. If you spill, you go under the water. Okay? Well, hopefully you don't get that much on you. Okay, so once you get that, then that's going to follow after in here. So this is step 1, this is step 2. Okay? When you put that in, what will happen is the acid will come in the bottom and it will be red because the universal indicator will turn red. So you'll be able to track where your acid is. That's the important thing. That's why we put the indicator there. Then you're going to get some water that is in a container. And you're going to pour it in here. That's step 3. But you're going to make sure that this is tilted at about a 45-degree angle while you're pouring it in. So you don't want the acid and the water to mix. So you can sort of track where the color is. It will start getting lighter and lighter red as you go up and finally disappear. So you want the acid to stay at the bottom. Okay? So don't pour it straight down in. Okay? Once that is in, you want the top to actually have a bubble of water on it. You're going to get a piece of magnesium ribbon from me, a strip of magnesium ribbon. You're going to take and weigh it. So I'm going to put it on a scale right here, and we're going to weigh it. Okay? Once you've got it weighed, you're going to roll that into a spiral. So the magnesium ribbon, just roll it into a spiral. The reason why is if you leave it straight, when it starts to react, it catches on the side of the burette tube, and then it finishes reacting because it goes out of where it needs to be. But the ball will sort of bounce off, or the spiral will sort of bounce off. So then what you're going to do is you're going to put this on top of here, that's 4, and put a cork on. The cork has a hole all the way through it, but you're going to put a cork on, and you're going to let that hole, as you're putting it on, let the water come up through the hole. Then you're going to put your thumb on it fast as you can, and you got a bucket full of water, and you're going to invert that into the bucket. This is my hole. I don't want it on the bottom. At that point, I can go ahead and hook it back up to the burette clamps. Okay, they sort of look like that, and it can just start the reaction. The magnesium ribbon will stay here for a while, but what happens is the acid will start to fall, and when it hits the magnesium ribbon, it will start to react and we'll get bubbles. The bubbles are hydrogen gas. Okay? So once the reaction is all done, okay, I'm going to just do another one right here, that the reaction is all over. Reaction is all over, and my water level's like right here. I'm going to take and I'm going to put my finger back over this hole, and I'm going to pull it back out, okay? I'm going to find the big graduated cylinders that are full of water that are in an ice cream bucket, and I'm going to put it down in, upside down, until the water inside and the water outside are the same level. That's equalizing the pressure, so that we can use the room pressure as our pressure total. You're going to read the volume in milliliters going down to the nearest tenth. Okay? When you're done with that, you clean up, put everything away, and come back in here. There's a couple of things that we need to have temperatures of. We need to take a temperature probe of the water. We need to know what the temperature probe of the water, or the temperature of the water is. We also, as we go back in, right around the corner here in the main lab, there's a black box on the wall. It's a weather station. We need the barometer reading, and it'll be in inches, and it's about in the middle. So look for something that's around 20 or 30 in the middle. You'll need that number. That's in inches mercury. You're going to have to change it to kPa. All right? All the instructions are on the front. The only thing that we haven't done is to use the string to hold the magnesium ribbon in. That just ended up being a pain in the butt. So we've gone away with the string. It works just as well without it. You just need to be quick after you put the cork on, turning it upside down and getting it in the water. Okay? I'll be back there with you. Gloves are mandatory. Aprons are mandatory. Okay? This acid that gets out into this area right here is very, very dilute. When you're done with it, since you guys are the last class doing this, I just want you to dump out the ice cream buckets. That's what they are. And just put them so that they will dry. All right? So sort of put them on the stand that's there, just sort of prop them up a little bit. All the girls are getting their hair up, and it's all right. Okay, any questions? All right, let's go. We're in the very back lab.